Hello everyone, welcome to Introduction to Electrical Engineering course. So in this topic we will discuss about the construction of a DC machine and its working. So when we say construction of DC machine, a DC machine it has a motor and as well as generator. Motor and as well as generator. DC machines is one is motor, one is generator. Generator means we know the mechanical energy is the input, electrical energy is the output. For motor it is vice versa. Electrical energy is the input, mechanical energy is the output. So here we are stated as construction of a DC machine, which means the construction of a DC machine is same for either it may be for motor or it may be for generator. So that's why we are not differentiating for construction of DC motor or construction of DC generator. We simply call it as construction of a DC machine. The same machine can be used as a motor and as well as generator. So first of all, let us understand what are the main parts of this DC machine. So here the main basic constructional parts of DC machine are we have two main parts. One is stator, one is rotor. Stator is the stationary part of the DC machine. Rotor is the rotating part of the DC machine. So in stator we have first one is yoke. We have yoke. This is the yoke. Second one is poles and pole shoes. Poles and pole shoes. Third one is field winding. So these are the three parts which are located on the stator of the induction motor. Stator means it is the stationary part of the induction motor. In rotor part we have armature and armature winding, and lastly we have commutator and brushes. So these are the main five parts of the DC machine, basic constructional parts of the DC machine. So first three parts comes under stator. So next two parts comes under rotating part. So let us understand what are these parts, what are the functions of these parts one by one, and later we will discuss about the working of the DC machine as a motor and as well as a generator. So a basic constructional diagram is shown here. This is the basic constructional diagram of the DC machine. So here you can observe we have a yoke here. The yoke is the outer frame of the DC machine. This is the outer frame. The outer frame of the DC machine is called as yoke, and this is made up of cast iron. Or steel. The yoke is made up of either cast iron or steel. So this provides the mechanical strength to the DC machine. So yoke means it is the outer frame of the DC machine. This provides the mechanical strength and it is made up of cast iron or steel. Next, coming to the pole and pole shoes. So here you can observe this is called as the pole. The whole part is called as pole, and this portion of the pole is called as pole shoe. The function of this pole is to create the magnetic field in coordination with the field winding. The function of this pole is to create the magnetic field, that is, whenever we pass a current through this part here, this pole, magnetic field will be produced. So the current passing through this pole is through the field winding. We can observe the field is connected here. This is the field winding. So function of the pole shoes here. Pole shoes, it serves for two purposes. One is it gives the support for the field winding. It gives the support for the field winding, and it also spreads the magnetic field produced by the field winding and pole uniformly in the air gap. So whatever the air gap we have here inside the DC machine, it spreads the flux uniformly. So that is the function of the pole shoes. Next, coming to the third part, that is field winding. So here you can observe on all the poles there is a winding. So whenever we pass the current through this winding, whenever you can observe here, all the terminals are brought to this terminal box. So here for the field winding we need to give the separate supply, that is DC supply. So whenever we pass the current through this field winding, the poles gets excited and the magnetic field will be produced inside the DC machine. So we need to use the separate supply for the DC machine for field winding supply. So function of field winding is to produce the magnetic field, and these poles are either bolted to the yoke by using the bolts and nuts, or either it may be welded to the yoke. Next part of the machine is armature and armature winding. This armature and armature windings are located in the rotating part of the DC machine. So here you can observe this part is the armature. Armature means it is a place where we place our generating conductors. So this is the armature. Here you can observe at the outer periphery of the armature there are slots. So in these slots we are going to place our conductors. Those conductors are called as armature conductors. Since we are placing on the armature part, those are called as armature conductors. So or it is also called as armature winding or armature coils. So here we are placing our windings. So this is the armature windings. So armature and armature winding is nothing but it is a place where we place the conductors is called as armature, and the armature, the conductors placed in the slots of the armature are called as the armature winding. So here next comes the commutator and the brushes. So whatever the conductors we have placed inside the slots of the armature, during the generator action, the EMF induced, the voltage induced in the armature winding is AC according to the electromagnetic induction and Faraday's laws. The induced EMF in the slots is AC. So this AC, but here we are talking about the DC machine, so the output should be DC. So in order to convert the generated AC EMF into DC, we are using the mechanical converter called as commutator. So here this is the commutator part. This is the commutator. So it will be having a segments of copper segments which are made up of copper segments. So this is the commutator which converts the generated AC to DC power. And this generated DC power from the commutator is collected with the help of the brushes. These brushes may be made up of either carbon or sometimes it is made up of graphite. So carbon brushes may be used or graphite brushes may be used. So brushes used to collect the current generated at the commutator segments. So here the commutator part is rotating, armature part is rotating when the rotor rotates, but the brushes are not rotating, they are stationary. So brushes collects the currents from the commutator segments. So this is the construction of the DC machine. So we have 5 parts mainly: yoke, pole shoes, field winding, armature and armature winding, commutator and brushes. Now we understood the basic functions of all the parts. Now we will understand how the given this DC machine works as a DC generator and as well as DC motor. So first let us consider for the DC generator case. DC generator case. First let me consider the DC machine working as the DC generator. DC machine working as DC generator. So DC generator means we know we give mechanical energy as the input, and output is the electrical energy. So first the mechanical energy to the DC machine is given with the help of the turbines, and rotor both are connected to a common shaft. So here you can observe this is a shaft. This shaft is coupled to the turbine. When the turbine rotates, the shaft connected to the rotor also rotates, thereby the armature also starts to rotate. So when the armature rotates, the conductor present in these slots, it is also in motion, right? The conductor present in these slots are also in motion. Now we need to apply the separate DC supply for the field windings, to create the magnetic field. So in these poles the magnetic field will be produced when we apply the DC supply. So now according to Faraday's law, whenever the conductor experiences the change in magnetic field, the EMF will be induced in the conductor. So the same principle is used here. Since in order to generate the EMF, we need three essential components. One is we need conductors, one more is magnetic field, and lastly the relative motion between conductor and magnetic field. So either conductor should be in motion or magnetic field should be in motion in order to generate the electrical power. So here when you give DC supply to the field winding, magnetic field will be produced, and this magnetic field is constant in the DC machine. That is, the magnetic field will be spread across the air gap in the DC machine, and which is constant. But the armature conductors, whatever the conductors placed in the slots of the armature, since armature part is moving, conductors are also moving. So here there is a relative motion between the conductor and magnetic field. So when the rotating conductors cuts the stationary magnetic field, an EMF will be induced in these rotor conductors, and this induced EMF is the alternating EMF. So this alternating EMF is given to the commutator, where it is converted to DC with the help of the commutator segments, and this generated DC EMF will be collected with the help of the brushes, and it is tapped out at the terminal box. So this is the working of the DC machine as generator. Now let us see the working of this same DC machine as a DC motor. So DC motor means we know the input is electrical, output is mechanical. So motor working principle is, we already know, that is whenever we place a current carrying conductor in a magnetic field, the conductor experiences the mechanical force due to the interaction of both the fluxes, the magnetic flux and the magnetic flux produced by the current carrying conductor. So the interaction of both the fluxes will have the force on the conductor, thereby the conductor starts to rotate. So that is the operating principle. Let us see the same thing in DC machine. So input is electrical, so whatever the electrical supply, we will directly give the electrical supply to the brushes. Through the brushes, it will go to commutator to the conductors present in the slots of the armature. So initially the armature is stationary here, right? Initially armature is stationary, shaft is connected to the turbine. We need to rotate this, that is the mechanical energy. So electrical energy we are giving to the armature conductors through the brushes and commutator, and again separate DC supply we should give it for the field winding to generate the magnetic field. So now when you apply the DC supply to the field winding, the magnetic field is produced, and when you supply electricity to the armature conductor, there will be currents in the conductor. So now the situation will be like the current carrying conductors, these are the current carrying conductors present in the slots. Current carrying conductors placed in a magnetic field. The magnetic field is produced by the field windings. So when the current carrying conductors placed in a magnetic field, the conductor experiences the mechanical force. Due to the interaction of both the fluxes. One flux is due to the field winding. The other flux will be produced due to the currents in the other flux is produced due to the currents flowing through the conductors. So when current is flowing through a conductor, it also produces the magnetic field. So interaction of both the fluxes will create the force on the conductor, thereby the conductor starts to rotate, the rotor also rotate, and the electrical energy is converted to mechanical energy. So that is the working of the DC machine as a motor. So the same machine can be used for motor operation and as well as generator operation. So this is about the working of construction of DC machine and its working. Thank you.